Okay, I'm going to do notes from section 812, and this is problem one. I didn't do them before because I did one very similar to them on another graph, but I've been asked to do these, so I'm going to do them. So we want to get the area between x squared plus 1, which is this parabola right there, and I'm going to stop from there to there because x equals 0 and x equals 1 are these vertical segments here. I'll stop there because of the next one. And then the y equals 0 is this x-axis right here. So the shaded part that I'm dealing with is this part right here. We got this part that is shaded. And now it says we want to rotate this. The axis of revolution is going to be the line x equals -1. So the line x equals -1 is, this is -1 right here for x. It is going to be this line. Oops, I don't want blue, I want green. Sorry. So I'm going to rotate that about this line. So we actually have kind of a funky deal here. Since this is the rotation thing, we're going to go around this thing, okay? And the radius is going to be from this thing way over here to the blue line. That's going to be the big R, and little r is the space. So I'm supposed to make rectangles, it said. So my big R is going to be from here over to here. That right there is my big R. So your big R is going to be the right equation, which is 1, minus the left equation, which is -1, which means the big R there is 2. Now, if you notice, there's space here where nothing's going on. So the little r on this one is going to be the open space from right there where the shading stops over to what we're rotating around. That's little r. This was big R down here. So little r there is going to be 0 minus -1, which is +1. Now, if you look, this thing is solid. There's a rotation going here. I don't really know what color to use. I guess I'm going to use black. This thing is rotating around this thing all the way back down to there, and it's going to be doing the same exact thing. The right minus the left is going to be the exact same up to this point right here. So we kind of got a little deal like this. Oops, I shouldn't have this part. Okay, and then there's a deal here, and then this is kind of solid here, and then there's like a donut, an empty hole in this part right here going over to there. So there's kind of a hole going there, and then it changes up here. Okay, so this is only going to go from 0 to 1 because this y value is 0. This is 1. Because when we rotate something around a vertical line, that makes our rectangles dy, because the change of our rectangle is the y value going up. So we need to solve everything in terms of y. So if I take this thing, I'm going to subtract 1 from both sides, and then I'm going to square root this. So it looks like x will be a positive negative square root of y minus 1. Well, if you look, the only part we're dealing with, well, actually, we're not even dealing with that one yet. We're only dealing with the blue and this. But they're going from 0 to 1 on these intersections. So just for this part I've got at the bottom so far, we're going to have the integral from 0 to 1, and then it's going to be a big R squared minus little r squared. That's the part not there, dy. So that is the first part of that's the bottom part. Now I've got to worry about the top part, because now the big R is still the same. My big R is still from this blue way over here to the green. So that big R part is still 1 minus -1. That's still that same thing, which is 2. But now the little r changes, and the reason it changes is because little r, the opening comes from this red part over here to the green. That is the little r on this one, and the red part is the parabola. So this is where this comes in, And since this is the right side of the parabola, we want the positive part because it's to the right. So this is going to be the square root of y minus 1 minus negative 1 again, which is plus 1. So then we're going to say plus. Now, we're taking this up here. This shaded part comes up here to where y is 2, and it changes to this red part here at 1. This was 0 down here for y values. So this is going to be the integral from 1 to 2. And that's going to be of the big R, which is the 2 we found up here, minus, and that's this little r part, which is going to be the square root of y minus 1, and then a plus 1. Let me erase this so we can see it. And then a plus 1, the quantity squared, and a dy. So this right here is what they want. Now, it actually didn't even say to find these, I don't think. Let's see, most examples were all, it does say find the volume. So all I'm going to do, I don't think I want to do this. I think I'm going to do this on a calculator just to save some time. I don't have to. I hope you see this is 4 minus 1, so this is the integral from 0 to 1 of 3 dy. And then over here I got the integral from 1 to 2, and this is going to be 4 minus, now this gets kind of ugly. I'm going to go ahead and do this. So I square the first term, so this is y minus 1. And by the way, it's this whole thing, okay? It's minus everything after this. I'm going to leave that there, y minus 1. And then it's going to be this times 2. So this is going to be plus 2 times the square root of y minus 1. And then I got to square 1 again, which is plus 1. So that right there is going to be my whole part over here. So then I would combine like terms. So this part right here is going to be 3y from 0 to 1 plus this part over here is going to be, I'm going to simplify this before I integrate, 1 to 2, and let's see, we got 4, and then I would distribute this minus sign. So this becomes plus, this becomes minus, this becomes plus, this becomes minus, this becomes minus. So I got 4 plus 1 is 5, minus 1 is 4, so I got a 4. And then I got this minus y, and then I got this minus 2, and then I'm going to put y minus 1 to the 1/2 power dy. So over here I'm going to have 3 times 1 minus 3 times 0 plus, and then over here I'm going to start integrating. So the integral of 4 is 4y. The integral of y is y squared over 2. And I got this coefficient of minus 2. And this part right here, I'm going to need to do u substitution. So I'm going to let u be y minus 1. Du is going to be dy. Okay, so I got a couple options here. One is I can go ahead and plug 1 in here and get 1 minus 1 is 0. So because I'm going from the y world, I guess I actually need to go right here and put that this is 1 to 2. Okay, because I'm leaving this in y, but I'm changing this to u. So I plug 1 in here, 1 minus 1 is 0, 2 minus 1 is 1. And I'm going to stick my u in there, du. So over here I've got 3 total from all this stuff, plus, now I'm going to go ahead and plug my upper bound in, which is 2. So I got 4 times 2 minus 2 squared over 2, and then minus, I'm going to stick 1 in there, so it's 4 times 1 minus 1 squared over 2, and then I got minus 2, and then over here I got to do this. So I'm going to add 1 to this power, so it's going to be u to the 3/2 power. 2 over 2 plus 1 over 2 is 3 over 2, and I'm going to multiply that by 2/3. I'm going to move this down so it doesn't look so weird. And then my interval on this is 0 to 1 still. So let's go down here and simplify some stuff. So this is still 3. Over here I got, let's see, that's 8. I got 8 minus 2. This reduces to 2. And I got a minus 4 and plus 1/2 right there. And over here I got minus 2. And then I'm going to plug in my 2. Well, actually, let's put this 2/3 and 2 together. Let's make this 4/3. And then I'm going to have 1 to the 3/2 minus 0 to the 3/2, which is 3 plus, let's see, that's 6 minus 4 is 2.5. minus distribute 4/3, and that's my answer, and I'm gonna quit. See ya.